Hello to all, I am Dr. Alkesh Agrawal, and in this lecture I'll mainly discuss about a special kind of combinational circuit, that is a multiplexer. So I'll discuss what is a multiplexer, then I'll discuss about the structure and the working of a 2 cross 1 multiplexer, followed by the discussion of design and the working of 4 cross 1 multiplexer, and finally I'll take on an application of a multiplexer, that is how to implement a given Boolean function with the help of a suitable multiplexer. So these are some reference books that include Digital Design, authored by M. Morris Mano and M. D. Saletti, and another book is Modern Digital Electronics, authored by R. P. Jain. So first of all, let us discuss what is a multiplexer. As you can see, this is the block diagram of a 2 cross 1 multiplexer. This is the block diagram of 4 cross 1 multiplexer. So multiplexer is a combinational logic circuit that has many inputs but only one output. Here also you can see we have many inputs and one output with some special inputs that are being termed as selection inputs. So here we have one selection input, we have two selection inputs. So in all we have these are as inputs I0, I1, S, and only one output. Here we have inputs I0, I1, I2, I3, S0, S1, and only one output. So this multiplexer, how it functions. So it is mainly a circuit that selects any one input from these so many inputs, and forwards the information that is coming on the input channel to the output channel. So out of these two input channels, the information is I0 and I1. So either I0 or I1 is being selected and forwarded onto the output. In the same case here, the information I0 or I1 or I2 or I3 will be selected and forwarded onto the output channel. The selection process is being done through the selection input. So that I'll discuss later on. So in brief, a multiplexer is a combination logic circuit that selects any one input from the given input channels. Now the input channels are in the power of 2 power n. So here power is 1, so we have two channels. Here 4 can be written as 2 ki power 2. So we have 4 inputs, or 4 input channels, 0, 1, 2 and 3. They are numbered at 0, 1, 2, 3, 0, 1, and the power of this value, that is 2 power 2, the power value gives the number of selection inputs. So here 4 is 2 power 2, so number of selection inputs are 2. Here the power of 2 is 1, so number of selection input is 1. If we have 8 cross 1, so 8 can be written as 2 power 3, so number of selection input will be 3, the number of input channel will be 8, and so we have 8 cross 1 multiplexer. So this multiplexer is also termed as many to one device, as it can combine the information of many users and forward it onto a single output channel. The main application of this multiplexer is in time division multiplexing, where the information of many users can be combined on and can be forwarded onto a single channel. So let us first discuss about 2 cross 1 multiplexer. So as the name suggests, 2 cross 1 multiplexer it has two inputs and one output. The selection line selects which channel input is to be selected, and that the information coming on that input channel is being forwarded onto the output channel. So let us see, when the selection input is 0, so information coming on this 0 channel I0 will be selected and forwarded onto the output. So here you can see in the truth table, when S is 0, output is I0. When S is 1, output is I1. So when S is 1, the information that is coming onto channel 1, that is I1, will be forwarded onto the output channel. The information of the truth table can be depicted in terms of Boolean function. So for this combination, S is 0, Y output is I0, we can write is S complement and I0, or S is 1, so we have S and I1. So when S is 0, this whole value becomes 0. When S is 0, S complement is 1, so what we get is I0. When S is 1, this value becomes 0, S is 1, so we get 1, and I1 is I1. So now we can see the functioning of this 2 cross 1 multiplexer with the help of this gate diagram. So we have 4 gates, 2 AND gates, 1 output OR gate, because we have only one output. We have 3 inputs, 2 channel inputs I0, I1, and 1 is selection input. So this selection input makes this gate or this gate on or off. So when S is 0, this complement output will be 1 and this output will be 0. So when S is 0, this gate will be on, this gate will be off, and through this gate I0 information will be routed onto the output. When S is 1, here the values will be 0, this gate will be off. When S is 1, this gate is on and the I1 information will be routed onto the output. Now let us see how this 4 cross 1 multiplexer works. So it is a combination, you can see it is a combination of 2 cross 1 multiplexer. So since as the name suggests, we have 4 inputs, 1 output and 2 selection inputs, S0 and S1. So you can see when the selection S0, S1 are 0 0 0 0, so that is equal to decimal equivalent 0. So information that is coming on this 0 channel I0 is forwarded onto the output, so Y is I0. When S0 is 1, S1 is 0, that is 0 1, that is equal to binary equivalent 1. So information coming on channel 1 I1 is routed at the output, so Y is I1. When S1 is 1, S0 is 0 equal to decimal equivalent 2. So this channel 2 is selected and the information coming I2 is forwarded onto the output, so Y is I2. When both in selection inputs are 1 and 1, that is equal to decimal equivalent 3. So information coming onto this channel I3 is routed onto the output, so Y is I3. So this is the Boolean expression for this 0 0 I0. What it can be written is S1 complement and S0 complement and I0. First term for this combination 0 1 I1, so we have S1 complement, S0 and I1. So this is the second term. For this combination 1 0 I2, we have S1 and S0 complement and I2, so this is third term. And for this 1 1 I3, we have when S0 I3 is the fourth term. Now the functioning can also be understood through this gate diagram. So we have 4 AND gates, 2 selection inputs through these inverters, and 1 OR gate which is forwarding the information coming out of this 4 AND gates. So one of the inputs of all these AND gates are the information inputs I0, I1, I2, I3. Now this selection inputs decides which gate will be activated and the rest of the gates are being deactivated. So when S0 is 0 and S1 is 0, so this output is 0 is turned into 1, and this is 0, this output is 1, and when S0 is 0, this output is 1. So this gate is activated, and at the through OR gate what we get is I0. For this gate you can see this output is connected to S1 complement. So for next is when S1 is 0, when S1 is 0, this output is high, so it is coming onto this input, and S0 is S0 is 1, so this is input at this point. So for next combination S1 0 and S0 0, this gate is activated and what we get at the output is I1. Then for third gate, this gate is connected through S1, so when S1 is 1, this is 1, its input is 1. Then when S0 is 0, this output is high, this is 1, so this gate is activated and at the output what we get is I2. For this gate we have S1 is 1, S0 is 1, so this gate is activated and at the output what we get is I3. Now let us see how we can implement Boolean function with the help of a multiplexer. So first of all, we have to do a simple mathematical calculation. That is, here we can see we have 3 variables A, B, C. So first we have to select a suitable multiplexer. So here you can see first we calculate number of selection lines. So number of selection line is equal to number of variables minus 1. So here number of variables are 3. So 3 minus 1 is 2. So we will take a multiplexer with 2 selection lines, and that suitable multiplexer will be 4 cross 1, because in 4 cross 1 we have 2 selection lines. So for a 3 variable Boolean function, we will implement it through 4 cross 1 multiplexer. If we have a 4 variable Boolean function, we will implement it through 8 cross 1 multiplexer, because there we have 4 minus 1, 3 selection lines, and 3 selection lines are in 8 cross 1 multiplexer. Now this can be implemented in 3 different ways, so I'll discuss one by one. So here you can see we have selected a 4 cross 1 multiplexer. So now as a selection input, I have taken input as B and C. So A input will be the main input. Now we have to decide what to give at channel 0, channel 1, channel 2 and channel 3 in terms of input A, because this selection inputs are being decided as B and C. So here we have a small table. In order to calculate the values of what is to be given at channel 0, 1, 2 and 3. So for this I have written I0, I1, I2, I3. Since I am taking main input as A, and from this table you can see A input is 0 for min term M1, M2, M3, M4. So I have written A complement for min term 0, 1, 2, 3, and A is 1 for min term 4, 5, 6, 7. So I have written A, and then after that in the same row I have written 4, 5, 6, 7. So that is for min term 0, 1, 2, 3, the value is A complement. For min term 4, 5, 6, 7, the value is A, because I am taking A as main input, and B and C are taken as selection inputs. So now I have to encircle those minterms which are given in a Boolean function. So those minterms are 1, 2, 4, 7. So I have encircled 1, 2, 4 and 7. Now I have to see column wise. So the basic rule is that if in a column both values are encircled, please again listen, if in a column both values are encircled, suppose this value is also encircled and this is already encircled, so it will be 1. If no value is encircled, it will be 0. But in this case, this lower value is encircled, that corresponds to A, so final value is A. In this column, this upper value is encircled, that corresponds to A complement, so final value is A complement. In this column, this upper value is value encircled, which corresponds to A complement, so we have A complement. And in this column, the 7 value is 7 min term is encircled, that corresponds to A. So what we give at I0, we'll get A, so we have given A. At I1, input is A complement. At I2, that is channel 2, input is A complement, and at I3, that is channel 3, input is A. So like this we have implemented this Boolean function with the help of 4 cross 1 multiplexer. So this is first case when selection inputs are B and C and the main input is A. Now let us take another case where the selection inputs are A and C and the main input is B. So here you can see this B variable here, this is 0 for 0, 1. So I have written for B, for 0, 1 min term, value is B dash, and again the value 0 is for these two, 5 and 4 and 5. So B dash, that is B complement, is for min term 0, 1, 4, 5, and B value of variable B is, that is 1, 1, is for 2, 3, 6 and 7. So again in the row for B I have written minterms 2, 3, 6 and 7, because for these minterms value is B, and for these minterms 0, 1, 4, 5 value is B complement. Again I'll encircle the minterms 1, 2, 4, 7. Again you can, now we have to analyze column wise. So here lower values encircled, that corresponds to B. Here in this column upper values encircled, that corresponds to B complement. In this column upper values encircled, that corresponds to B complement, and in this column lower value is being encircled, that corresponds to B. So again inputs are B, B complement, B complement, B, as it is calculated out through this table. So this is second method of realization where input selection inputs are A and C and main input is B. Now let us come on to the third case where selection inputs are A and B and the main input is C. So here you can see, here C, we have alternate values 0 1 0 1 0 1 0. So what we have written again, C complement and C, and you can see this is 0 1 2 3 4 5 6 7. So from this you can table you can see C complement is for minterms 0 2 4 6, that is even values, and value is C for odd minterms 1 3 5 and 7. Now again I have encircled the minterms that are given in Boolean function 1 2 4 7. Again you have to calculate column wise. So in this column lower value is encircled, so this is it comes out to be C. In this column upper value is encircled, so final value is C complement. In this column upper value is encircled, so final value is again C complement. And in this column lower value is encircled, so value is C. So again inputs are C, C complement, C complement, C. So now you can check from any one of these that how these minterms are being uh, calculated or implemented through this multiplexer. So in the first case, how this information will be selected when B and C are 0 0. So when B and C are 0 0, this A is selected. So what we get is A is means 1, A is 1, B and C are 0 0. So we get M4 because A is 1, B and C are 0 0. So we get 4, M4. Then when C is 1, B is 0. So that is 0 1. This A dash is selected, A dash means 0. So what we get is 0 1 0. So 0 0. This is also 0, B is 0, and this is C is 1. So what we get is M1. When this is B is 1, C is 0, that is 2. This A dash is selected. So A dash is 0. A dash is 0, B is 1, C is 0, so that is M2. And when both values are 1 1, what is selected is A. So A means 1. So what we get is 1 1 1. So what is being implemented is M7. So thank you.